This week, we will talk about an important relationship between the object. That's the inheritance relationship. So we will talk about why we have inheritance relationship. So then we will talk about what is the protected member access specifier. And also in C++, we have a couple different inheritance. We have public, protected, and the private inheritance. So we will talk about what's different between those inheritance. And also C++, they provide the feature is we can support multiple inheritance. So during the inheritance relationship, the constructor and the destructor function, they will be called according to the base class or the ref class. So we see what are their order. But before we talk about the inheritance relationship, let me talk about the related object. So sometimes when we create the object, we find out they are related to each other. For example, in the past couple weeks, we create a account class. But if you go to a bank, you tell the teller, say, I would like to open an account. So the teller will ask you, do you want to open a saving account, checking account, or a CD account? Right. So the past 2 weeks, we created account class. Account class, we have ID, we have balance, we have date created. But also, we have different kind of account. So for different kind of account, should we just separately to create them individually? On the other hand, you see, saving account. Should saving account have ID and balance? Right, of course they should. And also saving account, sometimes we have minimum balance need to maintain. And also each month, you only can withdraw 3 times. So here you can see when we create account class, they are more general. But if we want to be more specific, we have the specific other account type. They still have the same data attribute as the account class, but additional to different type of account, they add their own attribute. So we can see account class and saving account, checking account, CD account, they all have ID and balance. On the other hand, we can say they are related to each other, right? So the relationship is they all have ID and balance. But to be more specific, different account, they also, different type of account, they have their own data attribute. So similar situation when we say the shape. Can you define a shape class? But sometimes we will say, what kind of shape? It's a triangle, 3 sides, or rectangle, you have length and width. Or the square, you have the sides with the 4 sides with the same size. So they kind of have the relationship. So when we implement all those classes, how should we, using the shortest syntax to implement all the classes? So the same thing, employee class, you have different employee, you want to calculate their salary. Some employee, they based on only the commission. Some employee, they only have base salary. But some employee, they have base salary plus the commission. So that's why when we do the object-oriented concept programming, we find out some object, they have relationship. Or we can say they are related to each other. But what kind of relationship we should identify to them? So we see the account class and the saving account class, for example. Account class, we have ID, balance, and the date created. For the saving account, if we want to implement saving account class, we find out, right, we have the ID, balance, date created as well. But addition to that, saving account, they have minimum balance need to maintain. They only have limited number of withdrawal they can do. So that's why sometimes when we create different classes, if they are related to each other, we can see data attribute, they are duplicated. So this one not only for the saving account, checking account, they all have ID balance and they created. So your CD account, they do have that too. So that's why here we invent the inheritance relationship. If the two class, they kind of related to each other, but when we see here, we didn't make the relationship yet. But we do see they have the common data attribute or the common behavior they all have. So that's why here, since the account class did create the ID balance and they created. So that's why here we add the inheritance relationship. So what is the inheritance relationship? So this arrow actually is inheritance relationship. So if two class, we make this arrow to each other, we mean this saving account inherited from the account class. So then with this inherited arrow, the ID and the balance, since we already define in the account class, we don't have to redefine in the saving account. Or here, let me use the other way. We just remove that for now. When we remove that, it's because we don't need to define again the saving account since you do the inheritance relationship. So the account class for those data attribute, they kind of also have that in the saving account. So this relationship is we call inheritance relationship. Inheritance relationship, this class inherited from, we call they are base class in C++. To be simple to understand, this one actually is we call parent class. So in C++, we call the parent class as base class. In Java, we call that superclass. So that's all mean the same thing. So then the child class inherited from the base class. In C++, we call that's the derived class. So once you have this arrow relationship, they kind of all the data attribute defined in the base account class. The saving account has that too. The child class has that too. So this one is we call the inheritance relationship. Inheritance relationship actually happen in many different places. That's why you can see base class, for example, student. Student have ID, has first name, last name, have date registered. So then student, to be more specific, can be graduate student, can be undergrad student. Shape, like earlier we said. So then for the shape, you have circle shape, triangle shape, rectangle shape, or the cube for everything. So when you create a loan, you have car loan, you have home improvement loan, you have different type of the loan. So the same thing like earlier we say the account. So when we have the inheritance relationship, actually they will help us to reuse the software because the base class, every data attribute in the member and the member function you created, once the inheritance relationship happen, they all being inherited in the child class, or in C++, we call the derived class. So in this week, our lecture file, we were using one example. We call that for the employee. So like earlier we say, the employee can be commission employee. That means the employee salary is calculated based on your commission rate times your sales. But sometimes your employee can be the base plus commission employee. That means you have your commission, how to calculate, plus the base salary. So you can see here, the commission employee become a base class. So here we can define the employee first name, last name, and your commission rate and your sales. So the salary will be the commission rate times the salary. So then the base plus commission employee inherited, you see the arrow, inherited from the commission employee. Why? Because how to calculate commission already defined in the commission employee. I just need to add the base salary. So then you see we have the inheritance relationship. So in this lecture file, we will using, in this week, the lecture, we will use all the employee class to demonstrate how to implement the inheritance relationship. So here, by the end of this lecture, this video file, I will show you how we implement the commission employee. So this one is the commission employee UML diagram. Okay, so that's why here we will have 5 private data attributes in the commission employee. So you have first name, last name, social security number, they are all string. So just like earlier we say, you need to have commission rate multiply your gross sales. So then, right, we have the constructor function. So our constructor function, you will pass all the information. So that's why your constructor function, you pass all the employee, first name, last name, social security, and we have the default value if you don't specify your gross sales and the commission rate equal to 0. So that's why sometimes we can allow the user to change first name. So that's why your setter function and the getter function. So the same as the last name, social security, and the gross sales and the commission rate. They all have their setter function. So here, that's all the getter and the setter. So then we have 2 additional getter function. The first one, to calculate the earning. So you know inside here, we just multiply the gross sales times the commission rate. So we return the earning. So then we just print the employee information. So from here, your UML diagram. So of course, we have our header file. Okay, so that's the header file. We define all the private data and the public member function. So that's the constructor function. That's the getter function. And the setter function for the private data. So that's the earning and the print. So here is the header file. So of course, your CPP file includes your header file and include all the member function implementation. So then we just call all the setter function to set to passing the parameter for the first name, last name, and the social security number and the sale and the rate. So then here, continue your getter function and the setter function, how to implement. That's very clear and straightforward. You guys all understand that. So I just ask you to download these 3 files, including the driver program, to run with that. So I just only go over, earlier we say the commission rate. So the earning. So your earning actually is commission rate times your gross sales. So when we print the employee information, we print the employee first name, last name, social security number, and the gross sales. So then here is your driver program. We just show you simple example. How can I create an employee? It's N-1. So then you give them the gross sales is 10,000. So the commission rate is 6%. So we can display the employee information. We also can update employees' gross sales and commission rate, and we display the information. So that's our base class. So the next lecture file, we will show more in detail about the inheritance relationship, have the child class implement.